Hello students, I am Dr. Krupa Rasane, Professor and Head ENC, Jain College of Engineering, Belgavi. This is the fifth video of Module 4 dealing with Power Electronics BE 7th semester Electronics and Communication Engineering VTU. In this module 4, we have been dealing with DC to DC converter, that is chopper, and we have been referring to the textbook Mohammad H. Rashid, Power Electronic Circuits, Devices and Applications. So coming to the content, we have been already looking into the step up and step down choppers, okay, in our previous videos, but now we'll be looking into some example problems with R and RL load with respect to the step down chopper. So the problem is, in this case, this is a step down chopper. In a DC chopper, the average load current is 30 amps and the chopping frequency is 250 Hz. Supply voltage is 110 volts. Calculate the on and off period of the chopper if the load resistance is 2 ohms. So the load resistance is 2 ohms. The input voltage is 110 volts. Okay, the chopping frequency is 250 Hz and the current that is flowing is 30 amperes. This is what they have given you, and you are supposed to find the on and off period of the chopper. So IDC is given as 30 amps, that is the load current. Frequency is 250, input voltage is 110 and the load resistance is 2 ohms. So the chopping frequency can be found as, a period can be found as T equal to 1 by F. So you will be getting about 4 milliseconds. And IDC, we know the formula is equal to VDC by R. Okay, and VDC for a step down chopper with R resistance is equal to D into V. So IDC can be made equal to, substitute VDC as D into V, where D is the duty cycle. Okay, so D into V upon R, and from this we can evaluate D, that is the duty cycle, which is equal to IDC R upon V. So that is equal to IDC is 30 amps into R is 2 amps and V is 110, and you will get the duty cycle as 0.545. You are supposed to find the on and off times. So now that we know the duty cycle, the chopper on period, we know the on period is nothing but D into T. Okay, so D is 0.54 into T is given as 4 into 10 to the power of minus 3. So that becomes equal to 2.18 milliseconds, right? And chopper off period is nothing but total time minus the T on time. So that way becomes equal to 4 milliseconds minus 2.18 milliseconds. So we calculate it and T off becomes 1.82 milliseconds. Now let us look at another problem. A DC chopper in the figure has a resistive load of R equal to 10 ohms and the input voltage is 200 volts. When the chopper is on, its voltage drop is 2 volts. So now here we are looking into a chopper voltage drop of 2 volts and the chopping frequency is 1 kilohertz. If the duty cycle is 60%, okay, you have to determine the output, average output voltage, the RMS value of the output voltage, the effective input resistance of the chopper, and the chopper efficiency. Okay, so they have said it's a chopper with a load. So we are looking at a step down chopper again, and this is the chopper. Okay, and what all is given is, input is given as 200 ohms, R is given as 10 ohms, and chopper voltage drop across the chopper is given as 2 volts. Obviously output will be V minus the drop we have to consider. Normally this is considered 0 ideally, but if the value is given, we have to take V minus VCH. Then the duty cycle is given as 60%, so take it as 0.60 and F equal to 1 kilohertz. So the average output voltage is VDC equal to D into the difference in the two voltage. Normal it is D into V, but now that there is a chopper drop, we are going to take it as V minus VCH. So VDC equal to 0.6 into V is 200 and chopper drop is small, that is 2 volts. So I'll be getting 118.8 volts as VDC. RMS value of the output voltage is evaluated as root of D into V minus VCH. So root of D is root of 0.6, 200 minus 2, so that V naught RMS value output will be 153.37 volts. Okay, so these two values we have got. Next, effective input resistance of the chopper we know is equal to V upon IS. IS is going to be same as the load current, right? That is equal to V upon IDC. And how do we evaluate IDC as VDC by R? VDC we have evaluated as 118.8 in the previous slide, divided by 10 and you should be getting 11.8 amps. So Ri becomes equal to V by Is, which is equal to V by IDC, and hence substituting the value, V is 200 and IDC is 11.88. I'll be getting the effective input resistance of the chopper as 16.83 ohms. Now we have to calculate the efficiency. For that, let me calculate the output power. So output power is nothing but equal to 1 upon T duration 0 to dt, duty cycle, D into T. So that is T on. So that is integrated with respect to V naught squared by R dt. So this I will be getting as 1 upon T 0 to T on. V naught squared is nothing but V minus VCH the whole squared by R, okay, into dt. Integrate it and we should be getting P naught equal to D into V minus VCH the whole squared by R. So substituting the values appropriately, I should be getting 2352.24 watts. Now evaluating for input power is 1 upon T 0 to T on V into I naught into dt. So substituting I naught as equal to V minus VCH by R and keeping the rest as it is, let us substitute. So substituting the values of V minus VCH upon R, okay, the input power is evaluated as 200,376 watts. So the chopper efficiency is defined as P naught by Pi into 100. So 2352.24, that is P naught, upon 2376, that is P input power, into 100, you should be getting efficiency as 99%. So we have been evaluating all required parameters. Let us move on to the next problem, that is a chopper is supplying an inductive load. Note that this is a step down inductive load, but the load is inductive with a freewheeling diode. The load inductance is 5 henries and the resistance is 10 ohms. The input voltage to the chopper is 200 volts and the chopper is operating at a frequency of 1000 hertz. If the on-off time ratio is 2:3, you have to calculate maximum and minimum values of the load current in one cycle of chopper operation. I hope you remember the maximum and minimum value formulas that we have derived when we did the step down chopper with RL load. And also you are expected to calculate the average load current. Okay. So we have all the formulas with us. So let us continue. So this is your step down chopper with a freewheeling diode and the RL load. So the given values are L equal to 5 henries, R is 10 ohms, F is 1000 hertz, the input voltage is 200 volts, T on is to T off. The ratio has been given as that is equal to 2:3. That means T on is, if it is 2, T off is 3. And the time frequency has been given as F has been given as 1000. So I'll get that as 1 milliseconds. Now that I know the value of T and the ratio T on by T off, I know T on is equal to T 2 by 3 into T off. Okay. So we also know that T is equal to T on plus T off. So T is equal to 2 by 3 into T off, substituting for T on plus T off. So in this case, I'll get T equal to adding of these. So this will be LCM is 3 plus 2, 5 by 3 into T off. So T off becomes equal to, right, 3 by 5 into T. I know T, so substituting the value, I'll get the total time period as 0.6 milliseconds. Know all the tactics of finding once we know, very simple. Okay, so and then now that I know the T off value, I can evaluate T on as T minus T off. So T on is equal to 1 minus 0.6 into 10 to the power of minus 3, right? So that comes to 0.4 milliseconds. So I know that T on is 0.4 milliseconds, and hence I can find the duty cycle. So duty cycle is T on upon T. So that is T on is 0.4 into 10 to the power of minus 3 upon 1 milliseconds. So that comes out to be 0.4. Okay. So we got the duty cycle now. We got the T on time and the T off time. And now this is you are asked to find the maximum value of the load current. The formula given in our previous videos for an RL load step down chopper is Imax, the maximum, because it goes from Imax to I minimum. So Imax is equal to V by R inside the bracket 1 minus e to the power of dRt by L upon 1 minus e to the power of RT by L minus E by R. Okay, E value has not been given to you, right? So we will assume that there is no voltage source in the load and hence its value is 0. So substituting, so I don't get a term this side. So Imax will be just this. Substitute all the known values. V as 200, R as 100, 10, and 1 minus e to the power of D is the duty cycle, that is 0.4. R value is 10 and the time period is given as 1 milliseconds. The L value has been given as 5 henries. So substitute likewise here for R, T and L and solve this problem, and you should get a value for Imax. So the value of Imax that we are getting is 8.0047 amperes. Similarly, a minimum value of the load current with E equal to 0 has been given. So this term which is there plus E by R, that term is gone. And I will have an expression for I minimum previously derived as V by R into e to the power of dRt by L minus 1 upon e to the power of RT by L in minus 1. Very easy to remember the formulas. Imax we have the E term this side, and for I minimum we have the E term on the left hand side. So just look into that, substitute the values, all the known values, and I should be getting the I minimum value as 7.995 amperes. Students, I ask you to please open your calcs and actually solve them and see whether you're getting these particular answers. If not, do get back to me and let's see where the problem is. Then you're also asked to find the average load current. So average load current is given as IDC equal to Imax plus I minimum. It's the average of the maximum and minimum value. Okay. So that is equal to IDC equal to, we know this is Imax and this is your I minimum divided by 2. I'm getting around 8 amperes. So almost it is very small ripple. So next problem, the chopper is feeding an RL load. Again, it's an RL load is shown in the figure with V equal to input is 200, R is 5 ohms, L is 5 millihenries and frequency is 1 kilohertz. The duty cycle is given, E value is 0, and suppose you are supposed to calculate maximum and minimum values of load current, average value of load current, again RMS load current, effective input resistance as seen by the source, and the RMS chopper current. So we have done these two earlier problem, right? And also the RMS load current we had not done. So let's see how we go about. We have all the formulas again. So this is your step down chopper with the RL load. E term is 0. V is given as 200. R is given as 5 ohms. L is given as 5 millihenries. The frequency of the chopper is 1 kilohertz. The duty cycle is 0.5. and E is 0. Okay, so if we let's find the chopping period first. Immediately, this normally is the first step that we do in any chopper problem. If the time period is not known, frequency is given, then you calculate the time period and get off with it. So 1 into 1 upon 1 into 1 milliseconds. So you will be getting, sorry, 1 kilohertz, right? So it becomes 1 milliseconds. Okay. So we have the formula for maximum value of load current as we have seen in the previous value. Substitute that all the parameters that we know. This value is 0 and we should be getting Imax as 24.9 amperes. Similarly, we have the I minimum value formula. Substitute all the values. D is 0.5, R is 5, time period is 1 milliseconds divided by 5 millihenries. So 5 × 10 to the power of minus 3. V and R is 205 and this term is 0. So substituting, I should be getting 15.1 milliseconds. So I got the I max, I got the I minimum, and average value of the load current would be I max plus I minimum by 2. So substitute those two values that I have got and I get the IDC value as 20 amperes. Okay, now we let us calculate what is the RMS load current. Again, this formula has been derived earlier. Okay, here I1 stands for I max and I2 can be standing for I minimum. So substitute these known values again. We have this formula calculated. This is under the root sign. We have derived it. And when I So substituting the values in this formula that we have taken from the previous slide. So I minimum squared is 15.1 squared plus 24.9 minus 15.1 by 3 plus I minimum 15.1, I max is 24.9. Just substitute it, put it under the root sign, solve it and you should be getting I naught RMS as 20.2 amperes. So students, please again try to get this answer. If not, get back to me. Next, we have to look into the RMS. So the RMS chopper current is nothing but ICH, that is the chopper current flowing through the chopper, that is equal to root of D into I naught RMS. So it depends on the duty cycle on off time because chopper turns on and off. So this value is equal to 14.28. There is a difference between the load current as well as this current. This current will be definitely less, that is chopper current, because when the chopper current is off, the load current will still be flowing through the freewheeling diode. So notice here that the load current will be more than the ICH because load current has to be 14.28 plus the current that is freewheeling when this chopper is off. That's why we get this particular lesser value. Then coming to the effective input resistance, we have Ri equal to V by S, Is. We know this is the source current. And source current is nothing but the average source current, which is equal to D into IDC. For that, let us evaluate IDC. IDC is duty cycle into the load current. We know I naught as 20, which is equal to 10 amperes you get. So the effective input resistance Ri equal to V by Is, which is 200 upon 10. Okay, that will come to 20 ohms. So the source current is equal to, depends on the duty cycle into IDC. Okay, IDC we have already calculated as 20 amperes. So in this particular video, we have been looking into certain example problems of step-down chopper operations with respect to R and RL load. You may notice that we have already completed the next part, that is principle of step-up chopper, and we have dealt with a few problems in step-up chopper. I think one problem I have dealt with. Okay. So, though this particular chopper is basically dealing with the Bloom's taxonomy of L1 and L2, L3 normally caters to solving problems. I have solved a few problems so that you are ready for the examination from all points of view. In the forthcoming video, we'll be looking now into the converter classifications. Okay, and let us see that what are these different classifications of chopper circuits and where they are basically applied and how does it work. Okay, so with this I finish with this particular video, and I thank you for your patience listening and hope you have understood, and if you have any doubts please do get back to me. Thank you so much.